Hey guys, it's Mrs. Coker. You guys told me you wanted to hear my voice, so here I go. Good luck. All right, we're going to start with this page, so go ahead and find it in your notes. And we're going to talk about today the parts of an expression and combining like terms. All right, so this first box right here, this is an expression. And why is it an expression? Because we don't see an equal sign. So when we look at this, we're going to break it into different terms. We first have variable terms. And variable terms are those numbers, the coefficients, and variables that are attached to each other. So our variable terms in this expression would be 7x, negative 5x, and yes, it's not just a subtraction sign. Now when we're looking in algebra when we're looking at expressions, we include the subtraction sign and turn it into a negative 5x, and we also have a 4x. Now the coefficients right here are the numbers next to the variable. They're the numbers that we'll be multiplying that unknown variable by. So in the first one, our coefficient would be 7. Our second one, it's negative 5. And our third one, our coefficient is 4. Our constant terms are those terms that cannot change. They're constant. There's nothing attached to them, so they will stay the same. So our first constant term is 3. Then we have our 8. And we have a negative 1 because we need to carry the subtraction sign and turn it into a negative number. All right, so let's look down below where it says combining like terms. We can simplify the algebraic expression by combining like terms. So we want to put it in the smallest form possible. And if we look right here, I'm going to let's first combine our variable terms. So we have 7x. We have a negative 5x, remember. We got to make that subtraction sign and keep it as a negative, and a positive 4x. So 7x plus a negative 5x gives us 2x, and then plus 4x is going to give us 6x. So again, 7x minus 5x is 2x, and then we're going to add it to that 4x, and it gives us 6x. Now I'm going to look at my constants. I have a 3, I have 8, and a negative 1. So if I combined all those together, a 3 plus 8 is 11, minus 1 is 10. So this simplifies down to 6x plus 10. Let's move down a little bit and practice some of these. I'm only going to do 2, and I think you guys can do the rest. I'm going to do with you guys number 1. I'm going to do number 1 with you guys, and I will do number 7 with you guys. So let's take a look at number 1. We only have 2 variable terms. They're variable terms because they both have variables in them. So if we have 3x plus 6x, it's just automatically going to give us a 9x. All right, I guys want you guys to do 3 and 5. Now let's look at number 7. I'm going to look at my variable terms. I have a 5x, I have a negative x, and I have a 3x. When I see that negative x, I automatically know it's going to be negative 1x. So if I need to, I can put a little 1 in there. Probably going to take up the whole spot. So if I have 5x and I subtract 1x, that's going to give me a 4x. And then I'm going to add it to the 3x, and that changes everything into a 7x. Now I'm going to look at my constants. Oh, actually, there are no constants. There's another variable term. Instead of the x's, now we have y's. So I'm going to look at my second types of variable terms that include a y. So I have a 7y and a plus 2y. Well, that's going to change into a plus 9y. Go ahead and try number 8. All right, now what happens when we have exponents? Terms with the same exponents or combination of variables and exponents are considered like terms. So if we have, like in this one right here, we have an x squared and an x squared. Well, they're like terms. Now, if I had a 5x and a 7x squared, they wouldn't be like terms. But because they share the same exponent, they do. So if I have a 5x squared, and I'm adding it to a 7x squared, that's just going to give me 12x squared. Go ahead and try number 10. All right, I'm going to do, let's see, I'm going to do number 15 with you. So this one right here. We have a squared. Those are, that was a b squared. We have an a squared. Are there any other a squareds? Nope. So we're just going to leave it like that. So I have a squared. I'm going to carry down. Now I'm going to look at, I have 7ab and a negative 10ab. Well, they are like terms because they have the same two variables together that are multiplied together, which is ab. So if I have a 7ab and a negative 10ab, that would be combined for a negative 3ab. And now I am left with just a b squared. So there's no other like terms. I'm just going to carry it down. It'd be plus b squared. I also want to do number 16 with you. So for number 16, I have some x squareds. Here's an x squared. I have a 4x squared and a negative 3x squared. I don't have any other x squared, so I'm just going to combine them. 4x squared plus a negative 3x squared gives me an x squared. So I'm just going to carry that down. Now, I'm going to see, hey, there's my constants. That's what showed up next. So I have, hold on, sorry. I have a negative 7 and a negative 6. They came next. So a negative 7 and a negative 6 would be a minus 13. And then I have one more set of terms that I'm going to look at. I have a 2x and an 8x. Well, that would become plus 10x. Now you think we're done, but we're not. The order that you should put these in when you have exponents is you would put the one with the largest exponent first. So I would put x squared. Then I would put 10x and then my constant. I would always put my constant last. So put the highest number exponent first, all the way down to your constants. Okay, look at number 17. We can use this with our geometric application, so in the area of geometry. If I was to find the perimeter of these shapes, I know I'd have to add up every side. So I would rewrite this as 2x plus 1, because that's this side, right? And I'm going to add it to x, which is right here. And then I'm going to add it to 3x. Now I want to combine like terms. So here I have my my variable terms. So I have my 2x, my x, and my 3x. If I was to add those together, 2x plus x is 3x, plus 3x gets us 6x. Now I'm going to move over to my constants. My constants is a plus 1, and I don't have any other constants in there, so I'm just going to write plus 1. Let me do, let's see. Let's do number 19 together. Now, if we're trying to find our perimeter, remember, we still have to add this side over here. And since it's a parallelogram, if we look at the properties of parallelograms, we know this side is congruent to this side. Also, this side is congruent to this side, so we'd have to add 3y minus 5. So I'm just going to add them all together. And I want you guys to go ahead and do that on your own now that I've set it up. I'm not going to fully move it out for you guys. Okay, let's do, I'm sorry, on 19, I'm not going to fully simplify it for you, not move it out. I don't know what I was talking about. Okay, I'm going to do number 20 with you. And again, we have to add up all our sides. I'm going to do it over here. And you have to use this whole side. So I'm going to have k squared minus 9k plus 23 plus k squared plus k plus k squared plus k. Oops. You know what? I'm going to erase this and try to spread it out even more. It's not letting me erase. There we go. Okay. Let's try this again. I told you guys, beware. The other teacher probably did a much better job than me. Anyway, I'm not even going to write them all out because I don't have enough room. What I'm going to just do is highlight. Let's start with our highest exponent. My highest exponent within my variable terms would be a k squared. So I have k squared, k squared, k squared, k squared. So I have 1k squared here. Which I'm going to write. That's a 1k squared. This is a 1k squared, 1k squared, and this is our 2k squared. So let's add those up. I got 2, 3, 4, 5, 5k squareds. Now I'm going to find my variable terms. Without exponents would be a negative 9k, sorry. A positive 1k and a positive 1k. So if I have a negative 9k, a positive k, that brings me down to a negative 8k plus another positive k, and that brings me down to a negative 7k. And last but certainly not least, I'm going to combine my constants. So I got a positive 23 and a negative 17, and that gets me to a positive 6. Ooh, I changed color. All right. So I want you just to complete number 19. And any of the other questions I told you to complete. And I will see you in our next session class.